Hello, my name is Xiaoyang Wang. I'm a lecturer in AI here at the Department of Computer Science, University of Exeter. So my research focuses on this question: how can we build AI system that can learn, plan, and make decisions effectively in complex and uncertain environments? I'm especially interested in scenarios where feedback, or what we call reward, is sparse and the system needs to make autonomous decisions. I study this question through two lenses, reinforcement learning and generative modeling. So what I find exciting in these questions, because they can come up in many really important applications. For example, a robot may need to operate in a new environment which it has not seen before. Or an AI system might need to generate outputs that satisfy different requirements at the same time. For example, the robot might need to find an object in a very efficient way, but also to follow a safe route. So my goal is to develop learning methods that can make these systems more efficient, more adaptive, and more reliable. So in a recent work, we studied how AI agents can make better decisions by using their own understanding of the environment. We study how AI agents can make better decisions by using their own understanding of the environment dynamics and also their estimation of the environment uncertainty. So instead of learning only from interaction with the environment by trial and error, we look at how an agent can learn what we call a world model. It's essentially a mental model of the agent, which has some understanding of the environment itself. So the idea is that with this mental model in place, the agent should not just react to what it already knows, but also with this knowledge they have, they should actively seek out new information that could help it to learn faster. I'm also interested in how can this mental model can help the agent to plan into the future in this environment. Because with an existing understanding of the environment already, it can look ahead in time, find different possibilities, and then pick one of the best to achieve this goal. So this method is for better sample efficiency comparing with just exploring the environment in a random way. At the same time, I work on the controllability of modern generative models, such as diffusion models. So diffusion models, they are a type of models that can generate images and videos. But one challenge is how to adapt these models to different goals without retraining everything from scratch, because that is very expensive. So in recent work, we studied modular ways to guide generative models so that they can remain flexible, but also adapt to different downstream tasks or requirements we put on it. I'm particularly interested in settings with multiple objects to balance or with multiple downstream tasks, because that is often what happens in real-world applications.